In the previous lessons, we've already spoken quite a bit about variance. In this lesson, you will learn why a solid understanding of the concept of variance in your data is important to make better research design decisions. In his influential book Thinking Fast and Slow, Daniel Kahneman recalls watching men's ski jump. Ski jumping is a discipline where the final score is a combination of two separate jumps. While watching, he was startled to hear the commentator's prediction. The commentator in this case said the following: "Norway had a great first jump. He'll be tense, hoping to protect his lead and will probably do worse." Or, "Sweden had a bad first jump and now he knows he has nothing to lose and will be relaxed, which should help him do better." In his book, Kahneman points out that the commentator has discovered a pattern and built a story around it. Although plausible, and maybe also correct, the commentator had observed something that we can explain using the concept of variance. Can you imagine how variance applies to the text on your screen? This is what our bonus lesson is about: regression to the mean. Regression to the mean happens because values are observed with random error. Random error is the non-systematic variation in the observed values around a true mean. Later in this course you'll learn that someone's score equals true score plus or minus error. This means that every sportsman, just like every employee, has a certain average true score and an average error. This looks like the following. In this picture you can see that the true mean is around 50. This can be the number of deals per month for a B2C sales employee, for example. The true score of the person on your slide is around 50. But due to variation in performance, the person will sometimes make 30 deals and sometimes 70 deals. However, most of the deals will fall between 40 and 60. Compare this to the ski jumper in our example. If the same picture applies to their scores, you would expect them to jump around 50 meters on average. If they have a very good day, they might jump 60, 70 and sometimes maybe even 80 meters. However, once they have jumped 80 meters, the next score is very likely to be around 50 again, as that's their average or their true score. This principle applies to one person, but it also applies to a population. The following picture is an overview of a full population. The normal distribution of the population will have more variance than a specific person. The more people you add, the larger the error becomes. All the single subjects you see in this picture have a small variance, but all combined creates a larger variance in the population. Now this makes intuitive sense. Your good performers may have good and bad weeks, but in general they still outperform most of the rest of the population. An example in this picture of a great performer is the subject at the right bottom corner of the picture. This person closes between 90 to 100 deals on average per month. This is a score that most of the other subjects will never reach, even with all the luck they can have. So again, score equals true score plus or minus error. And for some people, their true score is just much higher than for other people. And these are your good performers. Now, this formula and this realization is of particular importance when an intervention is applied between two measurements. Imagine the scenario in which turnover for the past year has been very bad and hit an all-time high. To reduce turnover, the People Analytics team is directing all its resources to solve this. And you are in charge of proving if these efforts help. What will you see? Well, as you may understand by now, you will be very likely to see a decrease in turnover, which may make some people very happy, as it could be a sign that all the invested effort was effective, right? Well, not necessarily, because it could just be an exceptionally bad year, with turnover in the next year going back to the mean again, aka regression to the mean. Keep in mind that these extraordinary scores are also the ones that will provoke the strongest reaction and get the most attention. The point is that even without the extra attention, the score would still go down. This might fool your analysis though, because it sees an intervention and it sees a score going down. even though this effect is just a normal regression to the mean that would be there anyway. So the big question is, how can we reduce regression to the mean? There are a number of ways we can tackle it. First, there is a possibility to calculate the regression to the mean effect. Using the standard deviation, the within subject variance, the between subject variance, and the correlation, you can calculate the regression to the mean effect. I'll add the relevant formula and an article describing how this works in the reading material attached to this module. Second, you can reduce the effects of regression to the mean by using a smarter research design. You can, for example, have a random allocation to comparison groups. You can do this by using two groups, a so-called placebo group and a treatment group. The placebo group doesn't get the intervention, but the treatment group does. If participants are randomly selected, you would expect both groups to equally be influenced by regression to the mean, so you can correct the treatment group for the effect that has been seen in the placebo group, as that effect is assumed to be caused fully by the regression to the mean. You can also take multiple baseline measurements. This picture shows the reduction in regression to the mean effect due to taking multiple baseline measurements. This way the error cancels itself out over multiple measurement points, so you reduce the error and the true score becomes more visible. You can also correct for regression to the mean in your data analysis. After calculating the regression to the mean, you can subtract the estimated value from the observed change to give an adjusted estimate. The details for this procedure can be found in the reading material. Second, you can use an ANCOVA, which is an analysis of covariance, similar to the ANOVA, which stands for Analysis of Variance, which you'll learn more about in Module 3. What I hope this bonus lesson shows you is how relevant general statistical knowledge is for how you conduct your people analytics experiments. Methodology and statistics go hand in hand. So this bonus lesson is a good introduction for the second module, in which you will learn more about methodology. With this bonus lesson that takes a deeper dive into the concept of variance, you will also have a better understanding of how people score, perform, learn, and so on. To make it even more practical, try to apply this concept on an engagement survey that has been done in your organization. There are always a few questions that have a particularly low score. Next, management is incentivized to improve the scores of these low-scoring questions, and next year they are usually successful in doing so. Now, has this been caused by all the additional attention, or has this just been caused by an effect called regression to the mean? If you measure a lot of different questions, there will be a few outliers that have a larger negative error and thus a lower score. A last interesting piece of knowledge that I would like to point out is the differentiation in literature that's made between normal performance and top performance. The first I read about this is in Thomas Gamora Premzak's brilliant book The Talent Delusion, which isn't about statistics but still a book I recommend nonetheless. According to Thomas, everyone has a certain level of normal performance and a certain level of top performance for when you really need to give it your all. Now for some, these two are very similar. These are usually very conscientious people. For others, these two are very far apart. These people can be much more effective if they give it 100%. This is also similar to the concepts we've previously spoken about. When someone performs brilliantly in the first few months of their job but afterwards regresses to a much lower level of performance, we might have seen regression to the mean take place before our own eyes, influenced by the effort that the person puts in, regressing to their normal performance, their normal true score. Learning to spot and to recognize this will make you a better statistician and a better people analyst. I hope you enjoyed this bonus lesson, and there are a few more to come. See you there.